Hey everyone, welcome. Today we're going to continue our discussion on applications of quadratics. So this is day 2 of applications. First, a rectangular bumper sticker is twice as long as it is wide. If the area is 24 square inches, find the dimensions. So when you are given a word problem, I always suggest the very first thing you should do is draw a picture. We're talking a rectangular bumper sticker, so here's my rectangle. And the dimensions say it's twice as long as it is wide. So the length, here I'll call this my length, is going to be twice the width. W, I'll go ahead and leave as width. The total area is 24 square inches. So what I need to do is find a way to relate all three of these things. I have width, I have length, and I have area. Well, what we know is that the formula for area of a rectangle is length times width. So all I'm going to do is replace the L, the W, and the A with the information that I've been given. So first, I know that A, my area, is 24 square inches. So I'm going to replace A with 24. I also know that L is 2W, so instead of L, I'm going to write 2W. And W, the only information I was given is that we're going to call it W. But now I only have one variable in this equation, and that's something I can solve. So I simply multiply, simplify each side completely, so I multiply the right to get 2w squared. And from here I need to solve. Since there is no linear term, we talked about this in our previous lesson together, since there is no linear term, this means I am going to solve by taking square roots. So I am going to isolate the squared term, or whatever's being squared, get that by itself. So just to make this a little easier to see, I'll switch it around. 2w squared equals 24. And I need to isolate that w squared, so I divide both sides by 2. Dividing by 2 leaves me with w squared on the left-hand side. And on the right, 24 divided by 2 leaves me with 12. From here, I need to get rid of that exponent on w, so I square root both sides. Don't forget your plus or minus. So now on the left, since the square root and the exponent cancel, I'm left with just w equals positive or negative square root of 12. Remember that anytime you have a radical, you need to simplify it completely. So I break my 12 down into 6 times 2, and my 6 I break down into 3 times 2. We're looking for groups of 2. My 2's pair up, and I'm left with w equals positive or negative, 2, and then what remains inside is this 3 that did not pair up with anything. So width is positive or negative 2 rad 3. Now, as we've talked about before, we can't have negative length, so since we're talking width, we're just going to ignore that negative and let width be positive 2 rad 3. So here we have our solution for width, 2 times the square root of 3. We need to find out what length is because the problem does ask us to find the dimensions. Not just the width, we need the length as well. So I'm going to go here to length. I know it's 2 times the width, and width is 2 rad 3. So 2 times w is 2 times 2 rad 3, and all I do is multiply these 2's together to get 4 rad 3. So I have found that my width is 2 rad 3, and my length is 4 rad 3. If you punch this into a calculator, you can approximate. W is approximately 3.5, and since we're talking inches, this is 3.5 inches. And length would be approximately twice that, which would be approximately 7 inches. So in response to the question, here are your dimensions for your bumper sticker. Next, a carpenter is making a tabletop as shown below. The total surface area is 39 square feet. So again, area is 39 square feet. I'll go ahead and leave the units out just to make it a little easier to see. I have length in my diagram as 3x plus 1. I have width in my diagram. They tell me that information as well, and it's x plus 1. So just like in the last example, I need to find a way to relate all three of these pieces of information: area, length, and width. Again, just like in the last example, I have a formula that does relate all three of these things, and that's the formula where area equals length times width. I'll go ahead and plug in the information they give me and use it to help me solve. Area is 39, and that equals my length, but my length, they tell me, is this 3x plus 1, times my width, which they also tell me is x minus 1. Since these are binomials, I go ahead and put them in parentheses, and that means I need to FOIL to multiply this out. So I'm going to go ahead and FOIL by first distributing my 3x. On the right-hand side, I then have 3x squared, and 3 times negative 1 is minus 3x. I distribute my positive 1 to get positive 1x, and 1 times negative 1 is minus 1. On the left, I still have 39. I'm going to go ahead and simplify. So I have 39 equals 3x squared minus 2x minus 1. And since there is a linear term, since there is a 2x in this equation, I am not able to solve by taking square roots. So my only options are I can factor, potentially, or I can apply the quadratic formula. So I am going to move my 39 to the other side of my equation and see if this is something I can factor. So on the left I have 0, and that equals 3x squared minus 2x minus 40. There's no common factor between all three of these, so I go straight to my diamond. On top I have 3 and negative 40, which make negative 120, and on bottom I have a negative 2. So I am looking for two terms that multiply to a negative 120 while adding to a negative 2. This would be a negative 12 and a positive 10. So I'm going to go ahead and rewrite my trinomial as 0 equals 3x squared. And instead of my minus 2x, I'm splitting it up with negative 12x plus 10x minus 40. I then split this down the middle and take out the common factor on the left, which would be 3x, leaving me with an x minus 4. And on the right, I may take out a positive 10, leaving me with an x minus 4. Since those x minus 4's match, I factor those out, and I'm left with a 3x plus 10. All of this is equal to 0. Now that I have factored, I go ahead and set each factor individually equal to 0. So x minus 4 equals 0, or you can have 3x plus 10 equal to 0. On the left, I find x equals 4, and on the right, I find that x can equal negative 10 over 3. Since we're talking length and width, I'm going to go ahead and approximate this negative 10 over 3 to about negative 3.3. We're going to go ahead and check to find my length and my width by plugging these in. I'll start with my 4. The reason that we're checking both of them, even the negative one, is because this is not W or L. This is X. This helps us find W or L. If I plug in this negative 3.3 and my length or my width stays negative, then I know that that cannot be my solution. However, if I plug it in and I have a positive length or width, this is still a valid option. So first I'll go ahead and plug in my positive 4. W equals 4 minus 1, which is 3. And my length, when I plug in a 4, 3 times 4 is 12, plus 1 is 13. So when I plugged in a 4, I got W is 3, and I got length is 13. Again, I still need to plug in that negative 3.3. However, if my length and width stay negative, then it cannot be an option. So I plug in W is negative 3.3 minus 1, which is negative 4.3. And since that width value is negative, this negative 3.3 is not going to work. So in response to the question, the dimensions of the tabletop are a width of 3 feet and a length of 13 feet. Go ahead and pause the video, make sure you sketch a picture, and try this one on your own. So going through, I substituted my area for 400, the length and the width values that I have, and I simplified as much as possible. Getting down to this point here, since I can't factor, I had to use the quadratic formula. So I applied the quadratic formula and simplified as much as I possibly could. At this point, I was able to take out a 2 from that radical, and then I took out a 2 from this entire numerator. Factoring out the 2 from the numerator brought me here, where I was able to cross the 2's out between the numerator and denominator. So what I found was that W equals -1 plus or minus the square root of 201. Now, since they ask us for the dimensions of the painting, I'm going to go ahead and punch this into my calculator to help me find the width. Then when I find that width, I'm going to go ahead and plug that in to find the length. So plugging this into my calculator, I got a positive 13.1 or a negative 15.1. The reason I have two answers is because we do have this plus or minus as part of my expression, so I wrote two equations. Now we know width can't be negative, so the width must be 13.1. I'm going to go ahead and plug that in to find my length. So 2 times 13.1 plus 4. 2 times 13.1 is 26.2 plus 4. So I have the width, which is 13.1, and the length, which is going to be 30.2, and our dimensions are centimeters. Since we have found the length and width as asked, we are done. We have two more to do, and these are slightly different than the last couple we've done. We're going to find the x-intercepts of the function. So remember, if you have a graph, when you find the intercepts, you're looking for where it crosses that axis. So if I have a graph of a parabola, and I ask for the x-intercepts, I'm looking for the points right here where the graph crosses the x-axis. So these 2 points both have y values that are 0, and that's what causes it to cross the x-axis. If I wanted the y-intercept, that would be where it crosses the y-axis, which would have an x value of 0. Since I want the x-intercepts, I'm going to go ahead and let y equal 0. Remember, this whole thing equals y. So I am going to, on the left-hand side, let that entire f of x be 0, and I am going to solve for x. So from here you have a few options. You can factor if possible, or use the quadratic formula. Since this is not factorable, I'm going to go ahead and use the quadratic formula, where a is 1, b is 3, and c is also 1. I have negative b, so negative 3 plus or minus the square root of b, which is 3 squared, minus 4 times a, which is 1, times c, which is 1, all over 2 times a, which is 1. This simplifies to negative 3 plus or minus the square root of 9 minus 4, all over 2. So I have negative 3 plus or minus the square root of 5, all over 2. Writing two equations, I have negative 3 plus the square root of 5 all over 2, and negative 3 minus the square root of 5 all over 2. And these are your two x-intercepts. So you can write ordered pairs with these if you'd like, where it would be this is your x value, comma 0 for y, and same for the second, this for your x value, 0 for y. Go ahead and try this next and last example on your own after pausing the video, and have an awesome rest of the day. Thanks so much for watching.